Good afternoon, everybody. Welcome to our webinar today. My name is Troy Patterson. I'm VP of Marketing. I'm joined today by my expert colleagues, Mr. Davide Villa, who is our VP of Sales, Global Sales, and Ingo Martini, who's our Director of Sales and Pre-Sales, Director of Pre-Sales and Support at Theme Park, for BeeGFS. So welcome, guys, and welcome everybody for joining. Today's webinar is Maximize Your Storage Investment with BeeGFS, a hot topic out there at the moment, which Davide and Ingo will walk you through. Before we start, I just want to go over some quick housekeeping with you. Davide, if you don't mind switching slides. We will have a Q&A that will take place at the end of this webinar. We expect it to run for about up to 30 minutes. Please use your Q&A tab that is normally at the bottom of your screen to write your questions in. As I said, we'll be addressing them all at the end. Please keep yourself on mute during this call. We have a lot of people joining. And this call will be recorded and shared with you all afterwards, as well as being made public. So we will get the recording out to you at the latest by Monday or Tuesday next week. Before I hand over to the team to do it, I just want to give you a quick update on the next slide, which is what's coming up in the world of BeeGFS in the next few weeks. As many of you know, ISC is taking place in Hamburg in the middle of June. We are actually hosting the BeeGFS user group Bug in Hamburg on June the 23rd from 8 o'clock to 12 o'clock. This event is open to all BeeGFS users, so the entire community, our customers, partners. We have limited seats left. I think it's about 20 seats left. So if you are interested in attending, reach out to any of us or visit the link there, which we'll share when we send out the recording. And we're also excited to be at ISC on our booth L40, which we're co-sharing once again with the Fraunhofer Institute, ITWM. And we'll be on, as I said, booth L40. So if you are going to be at ISC, please make sure you drop by and say hello to us and the team and learn about what's new from BeeGFS. On that note, I'd like to welcome our speaker to start off, Davide Villa, to take over.
Okay, thank you, Troy. So in this session today, we will look at what's going on in the storage market from a price perspective, price and supply perspective, and what that means in terms of storage strategy, how you can cope with what we are seeing going on in the market. I'm coming from the storage industry. I've been in this industry over 20 years. Shortage and oversupply is nothing new. They keep on happening. You go through ingestion and digestion period for the big hyperscalers, and since the demand is so highly concentrated from component perspective in a handful of customers, when they go into an ingestion period, they create a shortage, and then they need to digest what they procure, and this normally leads to an oversupply situation. The situation now is unprecedented in the sense that we are seeing a spike of the price that never has been seen before. So if we look at the price compared to what they were just 9 months ago, we see that the enterprise SSD are 2.5 times higher in terms of price than what they were just in September. And similarly, on the HDD side, the nearline SAS and SATA HDD, they are 2x the price of what they used to be. What does it mean? It means that if you budget to do a deployment, if you were budgeting to deploy 300 terabyte of storage, with the same amount of money today, you cannot even afford a 100 terabyte of storage. So this has an implication on your strategy. Let's look a bit more what's going on why we are in this situation now. So if you look back during the COVID time, the hyperscaler saw a spike of demand. They had to help enterprises for their working from home. They had to help a student setting up their infrastructure for studying from home, so they went through an ingestion period. And right after COVID, we saw that the demand of the component went down significantly because the demand for working from home and studying from home wasn't there anymore. So you can see that the enterprise SSD pricing went down from $200 per terabyte down to about 120 in 2023, and similarly, the price of HDD they went from $27 per terabyte to about $17 per terabyte. And then in 2000, what the vendor did on flash, it was easier. They reduced capacity as much as they could. They were losing money. They tried to avoid an investment to downsize their production. And by doing that, they were able to artificially move up a bit the price. But then at the end of 2024 and in 2025, what happened is that the AI step in and all the SSD vendor, they start benefiting from a demand that wasn't there before. And at the same time, the hyperscaler, they went into their ingestion period. So we experienced a situation where they had their traditional shortage period plus the incremental demand coming from AI. And now we are in a situation where price delta price between nearline SSD, enterprise SSD and nearline HDD were coming closer at 7x, but now we are in a situation where the delta price dollars per terabyte is higher than 10x. When you speak with the SSD vendor, they will tell you that they see the inflection point when the price goes 3 to 4x. At that point, it makes sense to deploy flash because it's not only faster, but it's also consume less power, it consume less space. It has a lot of incremental benefit. So at that point, it makes sense to talk about all flash deployments. When the delta price is at 13x, it doesn't make sense. So there is a space where you will need flash for performance, but HDD are still very, very relevant, and it makes sense to mix the two, combine the two technology to get the best of the two, the cost optimization and the performance. So changing the strategy, what does it mean? That's a provocative statement. The cheapest hardware you have is the one that you already have, the one you already paid for. There is nothing cheaper than that. And during this webinar, we will try to explain how to retrofit legacy hardware. Modern hardware is not made to last just 3-5 years. It can last much longer. And you can give new life by adding just a small portion of incremental flash to make the infrastructure still very relevant for current workload. The other idea is why not using flash you already paid for? If you have a GPU client, but also most of the CPU client, there is a hidden flash that is there to be used, but it's very rarely used. With Beyond BeeGFS on demand, we can enable you to pull those resources and get the best out of them. And then the third point we want to address today is to right-size the mix. We're not forcing customer to go all flash. Today, going all flash is not the right decision for most of the companies. So with BeeGFS, with the introduction of our latest version, we are supporting tiering, the ability to move data from the hot flash, where you have the NVMe drives, to the cold storage with HDD, but even to S3. And Ingo will elaborate a bit more on those topics. So with that, let me hand it over to Ingo. We'll give you a brief overview of BeeGFS and how to implement the strategy that I just outlined. Ingo?
Great. Thanks, Davide. Yeah, BeeGFS as a parallel file system is maybe already good known or well known, we can create a single namespace on everything that is storage that comes from a Linux server. So BeeGFS is complete hardware agnostic, and this gives us a lot of freedom to create solutions and use hardware that is already exists. We can combine different storage classes, qualities, flash, HDDs, object storage, different technologies on a network backend, and so on. So, and this is really something that helps customers to use existing hardware, installing BeeGFS on this, and then expanding this hardware maybe only with a few NVMEs that fits in the budget that you have a plan for this year or for next year. And then you have something that works as a kind of a hybrid storage, a few terabytes or petabytes on NVMEs, but also a lot of capacity on spinning this. And on the front end, BeeGFS is also more or less hardware agnostic. That means we supporting Ethernet, but also RDMA connections to the clients like InfiniBand or Rocky. And this works on a client. The client is installed on a Linux system on the GPU nodes or the compute nodes. And if you have GPU nodes, you also can use GPU Direct to access the data. The different storage classes are organized in storage pools. So you can decide exactly which data should live in which storage pool. And this depends a little bit on the life cycle of the data. If it is needed for compute jobs, you may want to have this on your NVMe or flash tier. If it's more a data repository, then maybe a HDD is the better place for it. Or even if you have a large sequential files or large files that you read or write sequentially, HDD is good enough for this, and you may also only need the NVMe for smaller portions, small file handling, and for some results, checkpointing and other stuff. So all over, the BeeGFS gives you the freedom to create a very flexible system. This can be expanded, can be shrink over time, and this is something where you can add capacity or performance or metadata performance as well. As it fits to your budget and your needs that you have on your cluster. If we talk about legacy hardware, that's something that's maybe a little bit of a bad taste, but these days, new or the hardware can live much longer than the normal cycle that it was a few years before. We saw usually in 10, 15 years ago, we had hardware cycles of 3 to 5 years. So HDDs are known that they lasting much longer. The big players, the big, I would say, cloud providers, they have a lot of analysts and checking how long they can use the HDDs before they have to replace them. And they're doing also a lot of calculations about power consumptions, rack space, and all these things. But what they have found out that a normal enterprise HDD these times can easily live up to 10 years without having more outages on the statistical basis. Knowing this means the typical life cycle of storage hardware replacements of every 5 years is something that's not technically not necessary. It may have some implication in power consumption and density when it comes to rack space. But on the other side, the hardware is there. New hardware is extremely expensive. And so it makes sense to have, even if it's only for a short period of time, to think about using this hardware for 2, 3 years longer until the price peak is maybe over. And the same is for enterprise SSDs. So usually you have these one drive write per day SSDs. And if you do the calculation, if you look really what you use on these SSDs or flash storage, you will find that most of the flash storage SAS or NVMe SSDs flash storage uses only 20 to 40% of their endurance after these 5 years. There are a few use cases with heavy writes on these SSDs where this is differently, but in general purpose used flash, this is way far away from the we are out and from not using these SSD any longer. And you can also see if you do this, with a parallel file system like BeeGFS, then you can combine different generations of servers, just different generation of storage in a one single namespace. And then you can have a very granular system to say, I want to have some maybe 3-4-year-old servers attached with some JBODs or HDD RAID controllers. And then we want to expand this existing storage with maybe some new servers having some NVMEs inside. And then we can combine this and using BeeGFS internal data management possibilities to move data around within the same namespace. Moving around means from a user perspective, nothing changed. And the idea is that the users can store their data on a single namespace and some data automation that can be a Slurm job manager, this can be some policies that you write for the data movement. They are responsible for bringing the data to the right position, to the right time, on the right hardware. So with this, the combination of these servers is quite easy. We are hardware agnostic, even if you have hardware from different vendors, storage, server-wise, we can bring them together in a single namespace. And this is a big benefit if you think about retrofits legacy hardware. Think about a single NVMe server these days. Sorry. A single NVMe server these days can provide easily 120 gigabyte a second on performance on NVMe's. Read and write, maybe more on the read side even. And this is a lot of IOPS, a lot of performance that you will get from a single server. You don't need to pay, I would say, for multiple petabytes. If you have a requirement of 100, 200 gigabyte a second, that's already not that bad. That usually 2 servers will be enough to get to this performance. Why should you pay for the rest of the capacity for a very expensive NVMe's if you can use this with 2 servers these days? That's something that sometimes people don't realize, that they can get a lot of performance without buying everything in Flash. Okay. Another topic, and this is something that Davide already mentioned before, is using resources that you have already bought. Maybe 1, 2, 3 years ago, maybe 2 months ago. Most of our compute nodes and GPU nodes, they come with additional NVMe's for temporary storage. So each of these nodes has some NVMe's. Sometimes they are only used for the operating system. Sometimes they have additional NVMe's that are used for temporary scratch for a single job that is running on this node. But most of these NVMe's are not used with the full capacity and the speed that they can provide. So if you look in a standard compute cluster or GPU cluster, you will see the NVMe's only partially used, sometimes less than 15%, sometimes up to 30%, but a big portion of the capacity is still available. And the idea is building a job-based parallel file system on these NVMe's so that you have an additional file system without buying additional hardware. So you can utilize these NVMe's within the compute nodes. That's hardware that you have already in place. You have the network already in place between these compute nodes. So you can also leverage these connections. And the only thing you need is installing a BeeGFS file system. And then you can do on a per job basis, creating a temporary scratch file system on the number of nodes that you want to have for a specific job. So you can isolate noisy neighbors if someone is creating heavy I/O with small files or maybe a lot of files on a Python script that is hammering your central storage. You can easily use the built-in NVMe's, creating there an isolated file system for this job. And then this job is isolated from your central storage. So this also helps you to reduce the peaks that you see on your HPC storage environment if you can isolate these, I would say, noisy jobs in their dedicated file system. Everything you need for this is installing the BeeGFS packages on these nodes so that the software is already there. And then we have a dedicated deployment script that you can run, and you give the number of nodes that you have, and then you can use these in this environment. This gives you the possibility to get more performance, more storage, without paying anything on additional hardware. How this looks from a technical perspective is You see on the upper layers, you see the compute layer. All of these nodes have some local NVMEs. And on these nodes, you can decide which node should belong to a single file system. So you can create multiple of these BeeGFS on-demand file systems on your cluster if you like. And then if you have a job that is running on 3, 4, 5, 100 nodes in parallel, you can create a dedicated job for this as dedicated file system for this specific job. And then you run this one single command from a Slurm pre job, and then it creates for you a file system using on each of these nodes the local NVMEs, putting them together in one single namespace. You can also do this and say every write operation should be local. So that means the node has nearly the same performance on writing because he can use his local NVMEs like he may do it already today with the jobs. But the benefit is all the other nodes can also read the data, and you're operating here on a parallel file system. You can also spin up multiple metadata services if you like on each of these nodes, a single meta service. So also the metadata performance can scale with this. And you can also use multiple NVMEs in each node to spin up such a file system. So it depends on the hardware that you have. You are very flexible to create their local file system. And this is something that you can combine with the BeeGFS tool that you introduced in BeeGFS 8, the BeeGFS copy tool. That's a parallel copy tool where you can give multiple sources and a single target, and then stage in, stage out data from a central repository. As you can see on the lower side, this can be a BeeGFS file system, but it can also be everything else that is POSIX conform. So it can be a Lustre, Ceph, whatever you want to have there or that you have already there. That means even if you have a central storage that is working on a different product than BeeGFS, you can use the BeeGFS on-demand file system for this scratch-based solution. Where beyond fits, it's clear that's something that you can organize, that where you have multiple nodes working on a single job. That's a scratch file system only, so there is no additional safety. That's important to understand that Beyond was designed to really build a super fast scratch and not a super reliable, long-lasting file system. Beyond is definitely a scratch file system, and it fits if you have checkpoint-heavy environments where you need this very fast local write performance. You can use it for AI ML training because you have these a lot of small files, needs cache, low latency from storage to the GPUs. That's something where Beyond is really fast because sometimes you can stay within the single server. You don't need even to go over the network for this. And this is really for a burst buffer that you want to have without expanding your existing central storage to be able to handle the peaks that you will see on specific jobs that you're running here. It's not a backup tier that sorry. It's really something that you need to have in mind. Your data should be you're on a repository that is safe, that has a RAID protection. It's nothing that you want to do on a Beyond because Beyond can fail if a GPU node needs a reboot, then your file system has some challenges. You will see some impact here, and you may have not access to the data that you have stored on this node during the reboot time. So that's really something that you want to have. The benefit also is you have capacity is the sum of all the node NVMEs, and the performance is also nearly linear. If you have 10 NVMEs, you will see that you get 95% of the sum of all the NVMe performance in a single file system, and that's more or less for free because the hardware is already there. Okay. How to handle these things within a single namespace. Therefore, we need tiering, and this is introduced with BeeGFS 8, starting for more than a year now. We have now BeeGFS 8.3 available, and this gives you the possibility to migrate data between different storage tiers. This can be between different storage tiers within the namespace. So that means you have one single file system with flash-based storage, HDD-based storage, and then you can move the files inside this file system transparent to the user. The user doesn't know where really the data lives on a physical way. So the user sees his data in his project photos, and job scheduler or administrators can move the data in the background, or you can create a policy that says files for a specific age can be moved if they are not touched for a specific time. All this is possible. And you can also move data to an object storage. And that's what we see on the next slide. We will find here a short overview about if you have a single file system, you see this in the middle of this picture, the repository file system. This can belong to different pools, flash-based pools, HDD-based pools. This can be new hardware, legacy hardware combined in a single namespace. And then we use the BeeGFS migrate command in BeeGFS 8 to move data between different storage pools, but transparent for the user. So this data is still in the same directories. From there, we can offload to the right side to an S3-based bucket. This can be on-premise, this can be on the cloud for collaboration, for example. If you want to push data to an S3 bucket that someone else can work there, or you can load the data from an S3 bucket into your file system to get fast access for this specific job. That's something that you can use BeeGFS remote storage targets for. And you can also do this as an archive tier with remote storage targets on AWS Glacier. That means we're also supporting here not only S3, but also S3 Glacier. So that's mostly used for tape outage. So bringing something to the archive. This can be on-premise, this can be in the cloud. We have some collaborations with a few vendors, for example, Crowd Data with the Extreme store that can use S3 Glacier to bring data to tape, but it's still visible in the file system. You can work with stub files here. So even if the data is no longer taking place on the flash and blocking there some capacity, the data is visible for the user and is stored on an S3 bucket in the backend. And on the other side, on the left side, we see BeeGFS on demand. That's the file system that runs usually only on a temporary job base on your compute or GPU nodes. And therefore, we have the BeeGFS copy tool. It's a parallel copy tool that's built in BeeGFS, where you can use multiple clients at the same time, copying data between two POSIX file systems and staging data in and out, getting results out, stored to the repository, and then maybe archive for this. Bringing this all together, we see that we have there a policy engine. This policy engine is built to organize the data around your file system. So that's really something we are proud of because we have introduced data management capabilities last year with the BeeGFS 8 version. And now we have really the full suite of tiering and possibility to use policies, using manual jobs, using job scheduler. Third-party software can use our API that we have built in. So to move data within the single namespace, but also to the file system and from that file system to an object storage. All this is built in. So that means you don't need third-party tools for this. You don't need tools for staging data in from another storage and doing some copies, rsync, scripting something around copy to get more performance. That's already all built in with BeeGFS. And the same on the back end. We're moving the data from BeeGFS directly into the object storage. We have the metadata from the object storage in our metadata database from BeeGFS. So we know exactly on which tier and on which storage bucket they are landing and all the information. And third-party tools like an HSM software or data management tools can also get this information over our API. So for example, if you have a data management software in place or a Labor information management system in place, this can ask BeeGFS and give the information where the data is stored, on which tape they are stored, on which object storage they are stored. And this gives you the freedom to combine and implement BeeGFS much deeper into your environment as you can do, as it was possible before. And all this is complete hardware agnostic. So you don't need to go to a single vendor buying all the components from one vendor. That's really something that's the beauty of BeeGFS, is the openness to say, if you have an object storage from one vendor, some block storage from another one, some NVMe server from a different vendor, all this can be combined in a single namespace and give you, I would say, something that you can work on with enough performance that you need for your environment, and not flash only to fit in every situation. And there, Davide, I hand over to you.
Okay, thank you, Ingo. Thank you very much for this in-depth webinar. So just to summarize, we outlined 3 ways to cope with the current shortage and price hike on the component. One is to retrofit legacy hardware. If you have a running system, don't trash it. Give it new life, add a bit of flash, and you will be amazed by the extra performance you can gain without breaking your budget. Beyond on the client side, you already paid for those flash. Use them. We give you the means to aggregate, pool resources, get the best performance, and without disrupting your infrastructure. Still working. If your main infrastructure is Lastre, Wake, Avast, you don't need to change. Just add on beyond to get extra performance. And then, last but not least, tiering. All flash would be nice, but it's not for everyone, and it's definitely not for now. So you can combine multiple tiers and get the best of performance, capacity, and price optimization. Okay, that's all we wanted to present for today. So I think we can now open up for Q&A.
Yep. Thank you both. So we do have some questions that are coming in. For those of you who joined later on in the call, if you do have some questions, please drop it in the Q&A chat thing on your Zoom account right now. We'll go over some of these questions. Davide, my first one is my favorite one. It comes up a lot. I'm going to throw it to you. Is BeeGFS open source?
BeeGFS, we say source code is available. What does it mean? It means that we, as Theme Park, we are the only company developing a BeeGFS roadmap, and we make it available to anyone. So if you want to use BeeGFS without paying for a license, you can download from our website the community version, and the community version enables you to use BeeGFS up to 1 petabyte for your own usage. The community version comes without data management features. So if you need quota, if you need tiering, if you need S3, etc., you need to upgrade to the enterprise version. And in this case, you need a different license from us. And that's the only type of license that can be sold by the partners. So you cannot get support on BeeGFS from any partner unless you have an enterprise license.
Okay, and everyone can download correctly and trial this enterprise features for 60 days on their website, right?
Correct.
Okay.
And we are happy to engage with anyone who wants to run a POC and give you best practice, suggest you how to use it so that you can experience yourself the benefit that it brings in your infrastructure.
Okay, fantastic. Ingo, some questions your way. Does BeeGFS support any type of erasure coding native, or does it rely on underlying OS hardware, slash hardware to provide RAID?
Okay, right now, BeeGFS does not support any additional erasure coding to the data. We're chunking our data into cutting them into chunks and storing them on storage targets, and there we rely on the underlying hardware. There is a project ongoing to add erasure coding for specific use cases. The challenge with this is performance, because someone has to do the erasure coding, and many of the time the client can do this. And therefore, this is a project we are working on. I think it's nothing that we can present today, and maybe also not at ISC, so it's a little bit of a long-term project. But for right now, we are focused on performance with BeeGFS, and therefore we rely on the underlying hardware. That's correct. Right now, we do not have erasure coding for native data.
Okay, but watch this space and we'll reach out to everybody in the near future if we have more update on that. Ingo, I have another question for you. We spoke a lot about Beyond. We're going to be speaking about Beyond, moving into ISC, obviously, and the user group meeting, and we got some announcements coming up um, with Beyond. But this is a question that's coming: is what would you say is your typical Beyond use case for AI?
Typical use case for Beyond is really uh, if you train your models, if you do some kind of yeah job-based high speed, low latency, and small file handling, then Beyond is a good fit to create a file system that is really built into the compute nodes, GPU nodes. You don't need the network connections to your central storage for this. And there is a lot of benefit because you can slow down, wrong, you can reduce the latency for this. And this gives you a big benefit for extreme low latency data access, especially if it comes to smaller files and these things. Expanding the jobs with a dedicated, isolated storage can help to speed up these processes extreme because you don't rely on your central storage and you can get much more performance than your central storage can bring. And it's isolated. That's the most benefit here that you can use.
Okay, some more questions have just flown in, so I'm just going to open these up. Lawrence, our good friend Lawrence is writing, is there any plan to support TV caching?
TV caching, yeah. That's something that's also developed and worked on at the moment. We're thinking about what is necessary to do this. Beyond can be one expand one solution for this. Um, that means you expand your internal RAM within file system that's on the same system. But there is nothing written right now. So I would be happy to discuss the exact requirements here on an ISC meeting. So this would be very nice to get this. And yeah, that's what I can say at the moment here officially. Um, we are happy to get feedback on these requirements because usually we need this feedback from customers, from partners to get a clear picture on what we should add to our product and what maybe is necessary to use BeeGFS in their environments.
Great. Okay, Lawrence, we can hook you up if you can go for a meeting one-on-one. I know you're going to be at ISC. On the Tuesday night opening of ISC, we'll be having an open bar on our stand. Maybe that's a good time or another time during the day. Let us know, Lawrence. We'll book you in. Ingo, I think this is another one for you. Do you have any native SMB/Windows clients so data can be accessed both on Linux and Windows computers directly via BeeGFS software?
Yeah, there is a software package available from a partner that had developed their own Windows and Mac client. It's called Blink. The company is Elements. They are mainly active in the media entertainment world, and they wrote their own Mac and Win client together with our dev team. And this is in a proof of concept phase. So we have already a few customers running this. It really depends on what you like to achieve with this. This is a client, this is really for high performance. It's not a replacement for an SMB share where hundreds of students can connect their laptops and getting access to a central storage. It's really something where we're talking about streaming performance, high-speed performance, also connection over RDMA protocols, and therefore the Windows client has, I would say, some use cases. And if you are interested, I'm happy to get into a meeting, give you access to the software. At the moment, this is from ThinkPark side, it's a kind of a beta status because we want to learn with these proof of concepts what exact the application is doing. It's a little bit different than media entertainment applications like video cutting or rendering. They are working a little bit of a different way. That's why we do not officially get this out and say this is part of the BeeGFS software. That's something that we want to do in a kind of a controlled way that we say, okay, we want to see what the customer want to do. Then we want to support the customer during the proof of concept phase. And when it's working, then it's available, then we can give it to you. But everything about the Windows and Mac client goes over my table, so you're on the right right address. Connect, or I can reach out to you directly, and then we can uh, 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 create a proof of concept and see what is your requirement for the Windows client.
Okay, Ingo, we have a contact email address in there from Mads. Do you want to take that?
Yeah.
Yeah. Last question I'm going to throw over to Davide. We spoke about ISC, we spoke about how to download BeeGFS and test, and you spoke about the licensing. You're running global sales at ThinkPark now. How is someone going to get in contact with you or your team should they be interested in taking the next step and looking further into purchasing BeeGFS?
Yeah, get in touch. We have a global team now. We have people in the US, people in India, people in Europe, covering the entire world. The easiest way to get in touch is send an email to sales@teampark.com or info@teampark.com, or just drop me an email at davide@bgfs.io. As simple as that.
Perfect. Anyone, if you have any further questions, please reach out to any of the email addresses that Davide just mentioned as well. The marketing team will be sending out the recording of this, and we'll highlight those details that Davide just mentioned. So if you have any questions, come back and and we'll go from there. But thank you all for today for joining the call. Davide and Ingo, thank you for your time in the presentation. Hopefully we get to meet with everybody at ISC very, very shortly. Lawrence has just thrown up one question. No, it's gone. Lawrence, you can send it to me on email and I'll pass it to Ingo. But if anyone has any questions, please come to us. Would like to see you at ISC. Contact sales if you have any questions. Download BeeGFS and let us know. If you your thoughts if you do download it and your feedback. And we'll look forward to seeing you soon. Thank you everybody for joining our call today. Much appreciated.
Thank you. Have a good day.
Thank you.
You.
Bye.
See you soon.